Hi, this is Jay McClellan, and in this video I'm going to use my new 4th axis assembly for my Shark HD CNC router to machine a micrometer dial. I'm going to engrave the markings on the dial using the 4th axis. I built the 4th axis in the last 2 videos, so if you'd like to look at the build of the axis and you haven't seen those, you can check out those 2 videos. The part I'm making is a graduated dial for a micrometer carriage stop for my metal lathe. And it's based on a pair of videos by Tubal Cain. His YouTube channel is Mr. Pete 222. He has a lot of great videos out there and it's well worth checking out. In his video, he engraves the micrometer dial manually using an indexing head. And I'm going to make a similar part, but I'm going to make it on the CNC router. So this first video is going to focus on modeling the part in Fusion 360. And I'll model the part in CAD, I'll generate toolpaths, generate the G-code I need to machine the part. If you're not interested in that, just skip to the part 2 video. That's where I start actually doing the machining. Okay, so let's get started with Fusion 360. Fusion 360 can model cylindrical parts, and it can even wrap some types of toolpaths around the surface of a cylinder. But that doesn't work very well for text, and it doesn't work for the type of engraving toolpath that I want to use. I'm going to model my micrometer dial unwrapped onto a flat surface whose width equals the circumference of my part. And then when it comes time to machine it, I'll drive the rotational 4th axis from the x-axis output of the CNC controller. I'll show you how I do that in the second video. The following is going to be a tutorial on how I set up the CAD model and the toolpaths in Fusion 360. And if you lose interest or you just want to see some machining, then you can go ahead and skip right to the part 2 video where I actually start machining it. To model my part in Fusion 360, I'll start by creating a sketch. I'm going to select the XY plane where X is red, Y is green, and I'm going to create a rectangle by clicking on the rectangle button, then click on the center point, drag up and to the right, and I'll make my rectangle 75 millimeters wide, which is the nominal circumference of my part. I'll press Tab to switch to the other dimension and enter 20 millimeters, which is the nominal length of my part. Press Enter, and I have a rectangle. Next, I'll stop the sketch. I'll press E for extrude, select the rectangle I just created, drag it downward, and I'm going to enter -2 millimeters just to create a solid object. It's a little easier to work with than the flat sketch. Next, I'll model the tick marks that go around the edge of the dial. I'm going to create a new sketch, click on the face I just created, and I'm going to zoom in on the lower left corner, but not too far. Before I go any further, I want to select the entire rectangle, and I'm going to press X. That transforms the lines into construction lines, and that's going to be easy. They're not going to interfere with the geometry I'm about to create. Now I'll press R for rectangle, drag up and to the right. This is going to be one tick mark, and I'm going to make it 0.5 millimeters wide, and I'm going to make it 3 millimeters high. Now I'll zoom in on the tick mark I just created. I'm going to drag to select the entire rectangle, and I'm going to select Sketch and then Rectangular Pattern. And I want 10 of these tick marks, and I'm going to space them at 1.5 millimeters. My part is nominally 75 millimeters long, and so with 50 tick marks going around the circumference of the part, they need to be 1.5 millimeters apart. And if it goes the wrong way, which it did go to the left, you can enter -1.5 to get it to go in the correct direction. Now I have a pattern of 10 tick marks, but I want some of them to be longer than others, so I need to modify some of them. And I'm going to just arbitrarily pick this one to be my longest tick mark. I'm going to select that rectangular pattern constraint that I just created and press Delete. Now I still have 10 rectangles, but they're independent. They're no longer constrained to be a pattern of 10 identical things. And so I'll take the rectangle that I want to be longer, select the top edge, and just drag it upward. And you can enter a specific length. I'm just going to make an arbitrary length, somewhat longer than the others. So that would be 1, 2, 3, 4, the 5th one. And I also want, this is going to be where the numbers are, but I want the tick marks in between those to also be longer. And so 1, 2, 3, 4, 5 would be this one. This is like the halfway between tick mark. So if I select the top, zoom in a little bit, select the top line, I'll make that one just a little bit longer. So this is the pattern of tick marks that I want, and I'm going to want to replicate this pattern now 5 times to get my total of 50 tick marks. I'm going to make this top one just a little longer so it stands out. That's where the numbers are going to go. Okay, so to make a pattern of this, I'll select all of these, and again select Sketch, Rectangular Pattern. This time I want 5 of them total, and I want them to be 15 millimeters apart. Each of these patterns of 10, and I have to enter minus to get it to go in the direction I want. Press OK. Now I'll zoom out so you can see the whole thing. So this is my pattern of 50 tick marks that will go around the circumference of the part. I'll stop this sketch because I want to keep the tick marks separate from the other features, and I'm going to click on the sketch and rename it ticks. And as long as I'm at it, I'll rename the first sketch body, just so I can keep them straight. Now I want to put in the numbers, and so I'm going to create a new sketch. I want to keep these on separate sketches. It'll make the CAM toolpath generation simpler. So I'll select New Sketch, select this surface again, and I'm going to zoom in a little bit on where I want my first number to go. Now I'm going to add the text for the numbering on the dial, and I'll select Text here, and then click just anywhere near the tick mark where I want it. We'll tweak the position later. And make sure that this position dial is pointing upward. Depending on how the sketch is defined, it may be pointing downward. You want the text to be right side up in this view. And I'll enter the height of the text I want at 3 millimeters. And the text here is going to be 0. Press OK. Now I have a number, and I'm going to click in and click and drag on the number and put it down about where I want it. Right about there, right above the tick mark. Now what I want to do is make the text for the others, and to do that, click on the number to select it if it hasn't been selected already. Press Control-C to copy, and then Control-V to paste. If you're running on a non-Windows system, those shortcut keys may be different. And now I'm making a copy of this, and I'm going to enter for the X distance 15 millimeters is the offset for the copy. It'd be nice if you could replicate this with the pattern, the rectangular pattern option, but I haven't been able to get that to work. And so instead, I'm just going to copy these individually. Fortunately, I don't have all that many text items to create. So I'll just go ahead and create them all first. Move this over, select the one I just created, Control-C, Control-V, 10 millimeters, 15 millimeters, Control-C, Control-V. There we go. I'm using the mouse wheel to zoom in and out, and I need one more. And make sure it has selected the text and not one of these lines. That may have been why that one didn't work right. It's got to select on the text itself. Control-C, Control-V, 15 millimeters. Okay, so that puts my 4 text items located nicely, and now I'm going to zoom in and change the actual text on each one. Just double click. That's going to be 10. We'll move them in a moment. 20, 30, and we'll click the next one, 40. To position the text right above the center lines, just select it, and then you can click and drag. Okay, so now I have the text done, and I'm going to press Stop Sketch to stop that sketch. Before I go on, I'll rename the sketch I just created Text. Next, I'm going to define the knurling, and I'll press Create Sketch to put it on its own sketch. I'm going to select this same XY plane where I put the first one. And let me zoom to get it in view a little more. Now I could do the knurling on the metal lathe. I certainly don't need to do it on the 4th axis. I just want to do it as an interesting test of the 4th axis capability. So in the upper left corner of this sketch, I'm going to define the knurling, and I'm going to define it similarly to how I did the tick marks, except that it's going to be on an angle. It wouldn't have to be. I'm just going to do that because it makes it more interesting. So I'll press L for line. I'll select the upper left corner, and I'm just going to do this by eye. I'll drag down about what looks about right, maybe down to there. That's going to be the line defining the knurl. I press escape. I'm going to select that line, sketch, rectangular pattern. This is just a quick way to offset it in an exact distance, and I'm going to offset it by 0.5 millimeters, and I just want one of them. Okay, now I have 2 lines. I'll press L again, and I'm going to drag lines on the ends to connect these into a solid shape. So now I have one knurl defined as this little parallelogram. I made it half a millimeter wide, which should work out okay. I'm going to select that shape, sketch, rectangular pattern, and this time I want to go 1.5 millimeters apart, and I want, of course, 75 of them, because that is the overall circumference, the nominal circumference of my part. Okay, I'll zoom out so we can see the whole thing. Obviously that doesn't look right. I got the spacing wrong, and so I'm going to select on the rectangular pattern icon, right click, edit rectangular pattern, and I entered the wrong spacing. I wanted these to be only 1 millimeter apart, not 1.5 like the tick marks. So I'll change that to 1. Press OK. And that looks better. So let me zoom in so we can see that a little bit better. So these are the patterns that are going to define the knurling. Every millimeter I have a little strip, and I'm going to use an engraving toolpath to engrave these. And it should work out so that they just meet at the end. That is, I have one starting in the upper left corner of my part, and on the upper right corner I have a little gap before the previous one, and then the next one would start there since it wraps around the circumference. So that looks just right. And my CAD model is now done, and I'm ready to create toolpaths. I'll give my last sketch a name first. So I'll just call that knurls. And now's a good time to save the project, so we'll save it. And now I'm going to switch from the model view to the CAM view. And now I'm going to create some toolpaths. So first I'll create a setup, and I'll click on the setup button. And this is going to be a milling operation. I set up my model orientation in so the X and Y plane are where I want them to be, but I want my origin to be different, and so I'm going to select selected point for the origin. And if it hadn't selected this one, I would go click it, but it actually automatically clicked the one I wanted, which is in the lower left of the part. That's going to be where I set X, Y, and Z to 0, which will be on the front edge of the dial. And then under stock, I'm going to remove the offsets. So I want the stock to just fit the box that I have. That won't really affect the toolpaths, it's more for visualization. Press OK. And now I have my setup defined. Now I'm going to create toolpaths to engrave these. And I'll click 2D, Engrave, and select a tool. And under Tools, I've used it recently, so it comes up already with this 1/2 chamfer mill 1/4 inch V-bit. That's the tool I'm going to use. Press OK. I'm going to go to Geometry, and here's where you'll see where it's nice to have these on separate sketches, because I need to select all of these individual tick marks for the geometry. This first toolpath will be for the ticks. And a quick way to do it is to click on the sketch on which they're defined. And so that selects all of my tick marks, and I've got a toolpath now for engraving them. So let me go back and edit that toolpath, because there's one other thing I want to do. I want to set my cutting parameters, because the defaults aren't what I want. I want 15,000 RPM for my spindle, and I'm going to set my feed rate to 500 millimeters per minute. 1,000 is a little bit fast. It probably would work, but for what I'm doing, I'm going to set it to 500 a minute. It's mainly the cutting feed rate that matters. I'm not going to use lead in and lead out, and I'm not going to use ramps, so we'll leave those the same. So that looks good. I'm also going to check the heights, and this would work, but the retract height and these feed heights being so high slow the toolpath way down, and I really don't need to go up that high, so I'm going to change these all to 1 millimeter. Especially the feed height. That's the height where it starts moving slowly down into the part, and that doesn't need to be very high above the part. Since I've got 75 of these little slots to do, it makes a big difference in the machining time. The top height is the selected contours, and with engraving, the bottom height doesn't really matter a whole lot. It's nominally kind of big, 6 millimeters. The tool's only going to go down until it fits the width of the slot, and so that should work fine. We'll go to passes, and I don't need to change that. And then under linking, I think the defaults are going to be fine, and so we'll just press OK. Okay, now I'm going to simulate my toolpath. I'll press the simulate button, and you can play slowly and kind of watch it go. I'm just going to kind of jump to the chase here, but jump to the end. But it really looks better if you go up here and click this light bulb to turn off the model, so that all you're seeing is the stock and not the model, and then the simulation will just show you what's left. And so if I just run to the end, you can see these are what my tick marks are going to look like. I'm going to hold down shift and then press the center mouse button to orbit around a little bit. So yeah, those look pretty good. So that's just about what I want. Okay, so we'll close the simulation. That looks good. I was careful to get this toolpath pretty much the way I want it, try to get all the settings right, because I'm going to copy it, and so I wanted all the feeds the way I wanted, and so on. Now I'll turn this back on so I can see what I'm doing. I'm going to right click, and actually first let's single click on here, and we'll just name it ticks. And now I'm going to right click on it and select duplicate. And we'll just go ahead and rename while we're at it. And so this will be text, and edit this. Everything is the same except that I want different geometry, so I'll clear that, and then I'll select the text sketch. Sometimes that selection doesn't really work the way you want it to, and so I wish it would select all the text, but instead it selected the border. So we'll clear that. I'll select the text individually, and when you do this, it's really important not to click on this square box around the text, or that's what it's going to engrave. You have to click on the actual number to get it. And so I'll zoom out and then zoom back in so that I can get exactly the spot I want here. 30. 40. Okay, that looks good. Press OK. And I have an engraving toolpath for the text. I'm not going to simulate that one. I'll just simulate all of them. So I'm going to right click on it, duplicate, and then we'll name this one knurls. You could do the whole thing with a single toolpath. There's no reason to split them up. You can engrave it all in one because the settings are all the same. It's just easier for me because I want to generate separate G-code files for each one so that I can run them separately. So that's just a matter of personal preference. I could still generate a single G-code file for all three of these toolpaths if I wanted to. So I'll right click on the one I just created, edit, switch to geometry, click clear, and then I'll click on the knurls sketch, and it'll select all of the knurl contours. Press OK, and now that toolpath is generated. Now it runs off the end of the part here because Fusion 360 doesn't realize that this is actually wrapping around a cylinder. And so let me zoom out just a little bit. So the parts of the knurl that run off the edge here are what's going to fill in the gap here since it rotates 360 degrees. Okay, I'm going to click on the setup itself, not on an individual toolpath. I'll click simulate, and that'll simulate the entire thing. And again, I'm going to turn off the model so that I just have the stock, and we'll just run to the end. And there we go. So let me click up a little bit so we can see just the part. And I'm going to hold down Shift and then center mouse button to orbit around. So this is a pretty good indication of what the part's going to look like. The depth of the knurls would be deeper if I made those boxes wider. You can also adjust the depth on the fly just by changing where you zero out the Z-axis. And there's a little bit of randomness to that because it's hard to zero it out precisely with this kind of setup, but that's okay. I'm not worried about that. I just want to make some knurls, and hopefully they'll look good. So that's it for the model, and that's it for creating the toolpaths. All I need to do now is generate G-code files, but first I'll hit save. Save my project. And now I'm going to post-process each of the toolpaths. Click on ticks, and then click on the post-process button. And I have selected the DDCS V11 CPS. This is the post-processor that I wrote for the DDCS V1.1 panel and also for the CNC Shark controller. It works for both. That's the one that's out on my website. You can use that one, use a different one if you have a different machine. So that'll come up with whatever post-processor you had selected if you have done this before in Fusion 360. And my output folder is where I want it because I've done this before. And the program name or number, it's convenient to change this to the name of the toolpath when you post, because number one, it sets the name of the file name, and number two, that'll show up in the G-code as a comment. Everything else looks okay, so I'm just going to hit post. And I've done this before, so I have files already in that folder, but I'll just save it. Yes, and there we go. And I can do the same. Now you could select the entire setup and hit post, and it would post-process all the toolpaths into one file. But I'm just going to select the other toolpaths, and unfortunately you have to change this program name or number each time. I'll do the text, save, yes, and the knurls, post-process, enter knurls, post, save, yes. Okay, so my G-code is generated. You can inspect the files in a text editor to have a look at them and see how they work. But it's ready to machine, and the CAD model and the CAM processing are done.